For this next problem, which is y equals the quantity 2x minus 1 divided by the quantity x plus 1, we're going to do the same thing that we did on the previous problem. We are looking for horizontal asymptotes, which means we're going to look on the far right-hand side and the far left-hand side of this graph. So the first thing I'm going to do is actually just take the limit as x approaches positive infinity. And it's of the same, this expression right here. So if I evaluate here as x approaches infinity, that's 2 times an infinitely large number, which is infinitely large, minus 1, I'm still getting an infinity. In my denominator, infinity plus 1, still really huge. So now I have infinity divided by infinity, and this is an indeterminate form of a limit. We don't actually know what this equals if we just have this. We have to go back to the problem itself. So I'm going to show you more than one technique to do this, and really there are 2 things you need to think about when you're doing limit problems. Yes, there's the skill work, and that's number 1, but you also need to stop and actually think about what you're doing. So first technique, and I'm not talking skill or think about, I'm going to show you the first skill, and then there's another skill we're going to practice as well. But for the first skill, I'm going to find the highest power of x in the denominator. That's this x right here. This is x to the first. Now if this had been an x squared, I would choose it, whether that was an x squared, an x cubed, it doesn't matter. I'm not looking at the numerator at all. And if this had a coefficient, let's say it was 3x plus 1, I would ignore the 3. I'm looking for the highest power of x in the denominator. So what I'm going to do next is actually make this into a terrible mess, and I'm going to divide all 4 terms that you can see in this expression by this x. So I have the limit as x approaches infinity of 2x divided by x minus 1 divided by x, and you can see it was 2x minus 1. Now it's 2x over x minus 1 over x, all divided by x over x, which comes from this x here, plus 1 over x. So it's pretty horrible. My next step is to simplify it, but don't simplify by actually multiplying by an x over x. You'll undo everything you just did. But we're going to transform this into the limit as x approaches infinity. And if I look at this first fraction, 2x divided by x, I can cancel out those x's, so I'm left with 2. I'm not going to reduce this in any way or do anything because I really can't. X over x is 1 plus 1 over x. Now with my new expression, I'm going to take my limit as x approaches infinity and just apply the limit. So this would be a 2 minus 1 divided by something really, really big. And we know that 1 cookie divided by an infinite number of people, everybody's getting nothing. 1 divided by big is very small, so this is going to go to 0. If I look in the denominator, I again have 1 divided by infinity. That is going to 0. And I'm left with 2 minus 0, which is just 2, over 1 plus 0, which is 1. And the limit as x approaches infinity is actually equal to 2. So I have a horizontal asymptote at y equals 2. Now I need to look on the left-hand side of the graph. And what I want you to notice is where we actually plugged in the limit. This skill right here didn't actually matter for the negative infinity or the positive infinity. I haven't done anything. It could matter up here and it could matter down here. So let's say we do the limit as x approaches negative infinity of 2x minus 1 over x plus 1. 2 times negative infinity is negative infinity minus 1. Negative infinity minus 1 is negative infinity. And then in the denominator, I have a negative infinity plus 1. That is still a negative infinity. And I have a negative infinity divided by a negative infinity, which I could say is a positive infinity divided by a positive infinity. The point is that it's indeterminate. So what do we do now? Well, we would do this same skill piece right here. We would take the highest power of x in the denominator and divide each term by it. If I do that, I get the same exact expression here. So I'm going to skip this step and jump to this step. So I'm going to do the limit as x approaches negative infinity of 2 minus 1 over x divided by 1 plus 1 over x. And now I'm going to plug in a negative infinity. So this is a 1 divided by negative infinity. It's still 1 divided by a number that is just extremely huge in magnitude. It's negative, but it's huge. So this is still going to 0. If I look at the denominator, 1 divided by something huge is still going to 0. It's negative, but it's going to 0. So I'm still left with 2. So both of my limit expressions equal 2, which means that I do have just one asymptote, and my horizontal asymptote is located at y equals 2. Now this can be done with another skill, and we call that skill dominant terms. So if I look at this limit again, the limit as x approaches infinity of 2x minus 1 over x plus 1, I'm going to stop and actually think about the problem. Now when I plug in infinity, 2 times infinity is huge. Whether or not I add 1 or subtract 1, that's not really affecting the size of it as much. It's like 2 times a million minus 1. That's still really close to 2 million. And the further out we go, the less this negative 1 matters. So I would say in my numerator, the dominant term, the more important one, is the 2x. When I look in my denominator, the dominant term is the x. And you are looking for the term with the highest power of x in this case. Later we'll compare 2 different kinds of functions, but if both the numerator and denominator are polynomials, you're looking for the highest power of x. So I'm going to ignore the rest of the terms, and I'm going to relook at my limit. It's the limit as x approaches infinity of 2x over x, and if you look at what I have now, my x's actually cancel out, and the limit as x approaches infinity of 2 equals 2. It's the same answer I started with before. Now if I take a look right here, whether or not I plugged in a positive infinity or a negative infinity, it is not affecting the outcome. I would still have an x over an x, so that would be a negative infinity over a negative infinity. It still cancels out. I'm still left with 2. So there is only one asymptote for this problem, whether or not we actually look at each skill piece or stop and think about dominant terms and what that means.